Hello everyone, welcome back to my class. We are discussing module mechanics and we finished up to unit number 5. Today we are discussing the remaining units. In unit number 6, we are studying instantaneous speed and instantaneous velocity. Before that, we should know something about the motion of the object. For example, when an object is at a position, when the position changes, it will produce distance or displacement. When the position changes, that change in position can produce distance or displacement. From distance you will get speed, and from displacement you will get velocity. Then from speed or velocity you will get acceleration. So these are the variables when an object moves. So when an object is at a position, when the position changes, you will get distance or displacement. From distance you will get speed, from displacement you will get velocity. From speed or velocity you will get acceleration. So these are the variables when an object moves. So when an object moves, there will be change in position, there can be distance or displacement, and there can be speed or velocity, and from that you will get acceleration. So these all variables are changing with respect to time. As time changes, these all variables are changing. So when you draw a graph relating these variables with the time. So when you draw a graph, for example, from a graph, you can calculate two things. This is y-axis, this is x-axis. From a graph, you can calculate two factors, which are the one is area of the graph, second is gradient of the graph, gradient or slope of the graph. So from a graph you can calculate area of the graph or slope of the graph or gradient. So if the graph is like this, area under this graph looks like this, area under this graph looks like this. If the graph is a straight line parallel to x-axis, area under the graph is like this, area under the graph like this. So from a graph you can calculate the area. Area means area under the graph. So if the graph comes like this, there also will be area under the graph. This is the area under the graph. So from a graph you can calculate area. Another thing you can calculate, that is gradient. If the graph is like this, y-x, how will you calculate gradient or slope of the graph? In mathematics you learned slope of the graph or gradient of the graph equal to y2 minus y1 divided by x2 minus x1. So in order to get the gradient or slope of the graph, first you are making a right angle triangle anywhere in the graph. You can make it here, you can make it here, anywhere you can make it. So I am making the triangle here, and from the triangle you can get this is x1, this is x2, and this is y1, and this is y2. From the triangle you can get y2, y1, x2, x1. So if you take y2 minus y1 divided by x2 minus x1, the gradient of the graph will be, you will get it. So this is the way how to get the gradient of the graph if the graph looks like this. You can make triangle anywhere. If the graph is like this, or if the graph is like this, you can calculate the gradient by making a triangle. And here the graph is a straight line. It is making an angle theta with the x-axis. It is a straight line. It is getting an angle theta with the x-axis. Then the gradient is y2 minus y1 divided by x2 minus x1. How will you form? You are forming gradient from the graph. Y, x, this is a triangle, this is x1, this is x2, this is y1, this is y2. So you will get y2 minus y1 and x2 minus x1. You can make triangle anywhere. Corresponding y2, y1, x2, x1, you can measure it from the graph. So actually the graph gradient is, in mathematics it is tan theta. In mathematics, gradient of a graph is tan theta. So if theta is more, gradient will be more. If theta is less, gradient will be less. So for this graph, theta is less. For this graph, theta will be more. So this graph is having more gradient than this graph. So if a graph is a straight line making an angle theta with the x-axis, then by taking the by making a triangle on the graph, you can calculate the gradient of the graph. Then what will be the gradient of this graph? The gradient of this graph will be 0. What is the reason? Because tan theta is 0. Tan 0 is 0. Because there is no angle between the graph and the x-axis. They are parallel. Or here y2 minus y1 is 0. Y2 minus y1 is 0. So gradient will be what? Gradient will be y2 minus y1 divided by x2 minus x1. It will be 0. So if a graph comes parallel to x-axis, its gradient will be 0. Its gradient will be 0. So the graph can come mainly in two ways. One will be parallel to x-axis. If the graph is parallel to x-axis, gradient will be 0. If the graph is making an angle theta with the x-axis, they are making angle theta with the x-axis. So there y2 minus y1 divided by x2 minus x1, that is way for calculating the gradient. So these are the way how to get the gradient if the graph is straight. But if the graph is not straight, if the graph is not straight, how will you calculate the gradient? So if you want to calculate the gradient at this point, what do you have to do? Make a straight line only pass through it. Make a straight line passing through it. Make a straight line passing through only that point. That means this straight line is a tangent to that point. So if the graph is not a straight line, if it looks like this, how will you get the gradient at a point? So if you want to calculate the gradient at that point, you have to make a straight line passing through that point, then find out the gradient. Then find out the gradient at that point, because at different points the gradient will be different. At different points the gradient will be different because the graph is not a straight line. So if the graph is like this, the gradient of that graph, throughout the graph, the gradient will be same. But here the graph is not a straight line because it is making different angle with the x-axis. But here the angle is same everywhere. But here the angles changes. When you consider a graph like this, the angle is changing every time. Here the angle is theta. If you consider here, the angle will be different. So every time the angle is changing. But here the angle is same. Here the angle is same everywhere. See, this is theta, this is theta. So everywhere it will be theta. But if the graph is like this, the angle will be different. This is theta 1, this is theta 2, this is theta 3. The angle will be different. So gradient is, in mathematics, gradient is tan theta. So gradient will be different. So at different points, the gradient is different. So in order to calculate the gradient at a point, you make a straight line passing through that. That is the tangent of that, tangent to that point. Then you calculate the gradient of the graph by using the previous method. Make a triangle and you can calculate the graph. And you can calculate the gradient of the graph. So this is the way you are getting gradient from different types of graph. Then in this unit we are calculating, we are studying what is instantaneous speed. Instantaneous speed. What do you mean by instantaneous speed? Instantaneous speed means the speed of an object at a particular time. Because from one time to another, or as time changes, the speed is changing. When you look the speedometer of a vehicle, when you drive, when you look the speedometer of the vehicle, every time the speed is changing. So when you look at a particular time, you are seeing one speed, and after that time the speed is changing. So speed of a particle or speed of an object at a particular time, it is known as instantaneous speed, because the speed is changing every time. So we are measuring instantaneous speed at a particular time. Then what do you mean by instantaneous velocity? Instantaneous velocity is the same way. It is the velocity of the particle at a particular time, because the velocity is not a constant. It is changing from one time to another. So the instantaneous velocity is different. So we are calculating instantaneous velocity at a particular time. That's why the name comes as instantaneous. Instantaneous means at a particular time we are calculating the velocity. So these are the two types of speed when the speed is changing. When the speed is changing, you are always getting instantaneous speed only, because the speed is changing from one time to another. So we are calculating instantaneous speed or instantaneous velocity. Then if you are drawing a graph with the position and time, and if the graph is like this, what is the gradient of the graph? So the gradient of the graph means after position, what you are getting. After position, what you are getting. It is change in position with the time you are getting velocity or speed. So position with the time, change in position with the time, change in position with the time, you are getting velocity or speed. Velocity or speed. So from position time graph, your gradient will be velocity or speed. So here if you consider a triangle, this is x1, this is x2. Sorry, this is t1, this is t2. And this is x1, this is x2. Then gradient of the graph. Gradient of the graph equal to change in y, that is x2 minus x1 divided by change in x, that is t2 minus t1. So x2 minus x1 means change in position. Change in position, and t2 minus t1 means change in time. So gradient of this graph gives velocity or speed, because the gradient here it is x2 minus x1 divided by t2 minus t1. That means change in position divided by change in time. So you are getting speed or a velocity. So the gradient of a position time graph is speed or velocity. If I am drawing velocity time graph, if it is a velocity time graph, you are making a triangle here. This is t1, this is t2, this is v1, this is v2. Then what will be the gradient of the graph? So here gradient equal to change in y divided by change in x. Here change in y is change in velocity, that is v2 minus v1 divided by t2 minus t1. So it will be acceleration. So the gradient of velocity time graph is acceleration. So when the graph changes, gradient also changes. Position time graph gradient is velocity or speed. Velocity time graph gradient is acceleration. So velocity time graph gradient is change in velocity divided by change in time. You will get acceleration. Position time graph gradient is change in position divided by change in time. You will get velocity or speed. So from one graph to another, you will get different gradient. Then if you consider velocity time graph, what is the area under the graph? What is the area under the graph? So area under the graph, velocity time graph area is, you will get distance or displacement. Area under velocity time graph gives distance or displacement. So area gives the previous quantity of y. The previous quantity of y here it is velocity. So before y, what is the previous quantity? Distance or displacement. So area gives the previous quantity of y. So velocity, the previous quantities, it can be either distance or displacement. But gradient means next quantity of y. Here the y is velocity. So after velocity, what is the next quantity? It is the acceleration. So gradient gives the next quantity of y. Here y is velocity. So if you take the gradient of velocity time graph, you will get acceleration. But if you take the area of velocity time graph, you will get distance or displacement. So area gives the previous quantity of y. You check the axis, which is y, and take the previous quantity. And gradient means the next quantity of y. You check the y axis. If it is velocity, next quantity is acceleration. So from a graph, you will get two quantities, two factors, that is area and gradient. So from one graph to another, area and gradient are different. So depends upon the y value, the gradient and area will change. In unit number 8, we are studying different graphs. The graphs related with the motion. So if an object is at rest, how will you draw the position time graph? If an object is at rest, how will you draw the position time graph? If an object is at rest, how will you draw the position time graph? So here the position time graph is the object is at rest. Here the position of the object is not changing as time changes. The position of the object is not changing as time changes. So this graph represents object at rest. Object at rest. Object is at rest because the position of the object is not changing. So here the from this graph you can say the object is at rest. Then how will you draw the uniform velocity graph or constant velocity graph? You can draw with the position time and velocity time. Velocity time. So these two graphs represents what? The object with moving with the constant velocity. So here if you take the gradient anywhere, you will get the same value. That means the gradient of position time graph is velocity. That is a constant. Here the velocity is constant because it is a straight line. Look at that. The velocity remains same as time changes. The velocity remains same as time changes. So these two graphs represent same thing, but it is expressed in different variables with different variables. One is expressed with the position time, another is expressed with the velocity time. Then how will you draw graphs with the constant acceleration? With the position time, the graph looks like this. With the velocity time and with the acceleration time. So these three graphs represents same thing. That means the object is moving with a constant acceleration. If the object is moving with a constant acceleration, if you plot a position time graph, you will get this nature. And if you draw velocity time graph, you will get this nature. If you draw acceleration time graph, you will get this nature. So these three graphs represents what? The object is moving with a constant acceleration or uniform acceleration. So the same thing is expressed in with different variables in these three graphs, with the position time, with the velocity time, with the acceleration time. So these three graphs represents same thing. The object is moving with a constant acceleration. So these graphs are very important. So by looking a graph, by seeing a graph, you can understand what type of motion it is. The object is at rest, or object is in motion, or the object is moving with a constant velocity or constant speed, or the object is moving with a constant acceleration. So these all the things you can read from the graph. So by seeing a graph, you can understand what type of motion it is. So that thing you have to understand. So while doing numericals with a graph, you must read the graph. Then only you will get the correct answer. So what are the values in the graph? You must understand that by reading the graph, what type of motion it is. If the object is at rest, or the object is moving with a constant velocity, or the object is moving with a constant acceleration, or the object is moving with a constant variable velocity or variable acceleration. So these things you have to understand from the graph. In unit number 10, we are learning equations of motion. In unit number 10, equations of motion, you are learning. So equations of motion means what? They are equations which represents the motion of the object. So when an object moves, what will be there? A change in position. It is represented by delta x. So delta x represents change in position. Change in position, or it can be displacement. or it can be distance. Then delta t represents change in time. Change in time. Then A represents acceleration. Then Vi represents initial velocity. Initial velocity. Vf represents final velocity. So these are the variables when an object moves. There will be a change in position. Change in position produces distance or displacement. Delta t, that is change in time. A produces acceleration. There will be an initial velocity or initial speed, or there will be final velocity or final speed. So these are the variables when an object moves. These are the variables comes when an object moves. So by connecting these variables, we are forming the equation. By connecting this variable, we are forming the equation. That's why it is named as, they are named as equations of motion. So equations of motion represents what? They are equations which represent the motion of the object. They are equations which represent the motion of the object. So which are the equations of motion? There are 4 equations of motion. There are 4 equations of motion. First one is, you can form from the basic equation, that is A equal to Vf minus Vi divided by delta t. That is the acceleration equal to change in velocity divided by change in time. So by cross multiplying, Vf equal to Vi plus A delta t. So this is the first equation. Then next equation is Vf square equal to Vi square plus 2A delta x. That is equation number 2. Then delta x equal to Vi delta t plus half A delta t square. That is equation number 3. Then delta x equal to initial velocity plus final velocity divided by 2 multiplied by delta t. These are the 4 equations. These are the 4 equations, and these equations represents equations of motion. These equations represents equations of motion. So it contains initial velocity, final velocity, acceleration, time, distance or displacement. So they are known as equations of motion because they are representing the motion of the object. So from one problem to another, the equations changes. So when you do a numerical problem, you select an equation or you choose an equation that should contain one unknown. For example, if you are selecting Vf equal to Vi plus A delta t, if A is unknown, the other values you should know it, that is Vf, Vi and delta t. So when you choose an equation or when you select an equation, that should contain only one unknown. That is the way how to select the equation. So these are the equations of motion. So these equations we are using for solving numericals. For example, if an object starts from rest. So if an object starts from rest, initial velocity or initial speed will be 0. In some problems, some numerical problems saying the object is starting from rest, initial velocity will be 0. In some numericals, the object moves with an initial velocity and finally comes to rest. So the final velocity of the object is 0. So from one problem to another, the variables change. In some problems, the question starts with a body which is at rest. So initial speed will be 0, that is Vi will be 0. In some problems, an object is moving with an initial velocity and after covering a distance, it comes to rest. So in that case, Vf should be 0, that is final velocity will be 0. So from the numericals, you must read the numericals carefully and you should know which are the values given, and you must select an equation that should contain one unknown. That is the way how to do the numericals based on equations of motion.